Test, test. Okay, so hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So I also took my Bachelor's of Science at this institution as well in the Pharmaceutical Chemistry program. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with like homework or tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions for today's session. Okay, so question 1 asks, how do you find the molar mass of iron oxide? Okay, so to find the molar mass of Fe2O3, I need to find out what my atomic masses for both iron and oxygen are. So these are just values that you would find on your periodic table. The molar mass of iron is 55.85 grams per mole. And the molar mass of oxygen is around 15.99 grams per mole. So in this compound, you'll notice that there are 2 atoms of iron and 3 atoms of oxygen. So I'm going to multiply my molar mass of iron by 2. And I'm going to add it with 3 times my molar mass of oxygen. So now I can just plug in the atomic weights of these elements. Okay, so if I add up these values, I end up getting a total molar mass of 159.7 grams per mole. So let's see what our junior tutor said. In solving for the molar mass, we must consider the atomic mass of each element and multiply it to the number of atoms present, then combining all the products. For iron 3 oxide, there are 2 atoms of iron with an atomic mass of 55.85 grams per mole, while there are 3 atoms of oxygen with an atomic mass of 16 grams per mole. Computing for the molar mass will result in 159.7. So therefore, the molar mass of iron 3 oxide is 159.7. So this solution is correct. Okay, so moving on to question number 2. What is oxidation? So an oxidation reaction oxidation. So oxidation reactions are also known as like a half reaction. Meaning when you have a redox reaction, which is the full reaction, oxidation is one of the half reactions, whereas reduction is the opposite of oxidation. Okay, so moving on back, half reactions involve the loss of electrons, whereas A reduction reaction, which is also a half reaction, involves the gaining of electrons. So there are different ways people try to remember which one is which, like which one loses electrons, which one's gains. So there are different ways to remember. One of them is oil rig, which means oxidation is losing electrons and reduction is gaining electrons. There's also like Leo Ger. So losing electrons is oxidation and gaining electrons is reduction. So it all depends on which one you prefer to use. And I'll just have an example of both. So for an oxidation reaction, let's say we had lead solid, which just has an oxidation number of 0, plus 2 chlorine, so if we look at the lead, its oxidation number increased from 0 to +2. So this is an example of an oxidation reaction. It lost its electrons and it formed bonds with the chlorine. For a reduction reaction, in the case of like silver chloride, if the silver gained 2 electrons, it becomes silver solid plus just the 2 ions of chlorine. So here, again, you'll see that the silver, when it's bonded with 1 chlorine, has an oxidation number of +1, and its oxidation number decreases to 0. So this is an example of a reduction reaction. So I'll also note that at the bottom, when oxidation number increases, then the atom is oxidized. So let's see what our junior tutor said. Oxidation reaction refers to the half reaction that involves the loss of electrons. When a substance is oxidized, its oxidation number will increase. For example, zinc solid is oxidized to zinc 2+. Zinc lost 2 electrons and acquired a charge of +2. Also, its oxidation number increased from 0 to +2. So I can verify that this solution is correct. Okay, so moving on to question number 3. What is the mass of a mole of sucrose? So they actually gave us the chemical formula for sucrose, which is C12O22, H22, sorry, and O11. So when you want to calculate the mass of a mole, this is the same thing as finding its molar mass, which I'll denote as a capital M. So to find the molar mass of sucrose, it's simply the sum of all of the different atoms involved but I'm going to multiply them depending on how many atoms are in a sucrose molecule. So since there are 12 atoms of carbon, I'm going to do 12 times the molar mass of carbon plus 22 times the molar mass of hydrogen plus 11 times the molar mass of oxygen. So to find the atomic masses of each of these different elements, these are just the values you would find on your periodic table in grams per mole, or sometimes it's denoted as AMU. Still, the values are the same. So for the molar mass of carbon, it's 12.01 grams per mole. The molar mass of hydrogen is only 1.01 grams per mole. And the molar mass of oxygen is around 15.99 grams per mole. So now I can just add all these different values together, and I end up with a total molar mass of around 342.34 grams per mole. So let's see what our junior tutor said. The mass of a mole is known as the molar mass. To calculate the molar mass of a compound molecule, we use the equation below. The molar mass is equal to the sum of N times Mi, where N equals the number of atoms present in the compound molecule, and Mi is equal to the molar mass of individual element present. So here they just summarized how many atoms of carbon, hydrogen, and oxygen there are, and also their individual molar masses. And they added it all up and got their 342.34 grams per mole. So I can verify that this solution is correct. Okay, so now let's move on to question number 4. How many cups are there in a quart? So there are actually 4 cups in 1 quart. So let's just have an example. So let's say we have a question that asks how many cups are in, let's say, like 57 quarts. To solve for the number of cups, I'm going to do X cups over 57 quarts is equal to, and then on the right side of the equation, I'm going to write down the conversion factor, which is 4 cups in 1 quart. So now I just have to solve for X. I'm going to multiply both sides by 57 quarts. And you'll notice that our units for quarts should nicely cancel out. And we are left with a value in cups, so it's pretty much just 4 multiplied by 57 to get 228 cups. So let's see what our junior tutor said. There are 2 pints in a quart. In a pint, there are 2 cups. And then they just showed how they conversion factors and got 4 cups in 1 quart. So this solution is correct. Okay, so moving on to question number 5. How do you convert grams to moles to molecules? So step 1, grams is a mass value. Grams to moles is simply just using the equation number of moles is equal to mass over molar mass. So the mass is in grams, and molar mass are the values you would just find on your periodic table, and its units are in grams per mole. So the second part of the question asks from moles to molecules. So if we know the number of moles, we can actually multiply this value by Avogadro's number. And its units are in molecules per mole. Okay, so I'll actually write out the value for Avogadro's number. So depending on your teacher, sometimes they want you to memorize it. But it's not that hard to remember. It's just 6.022 times 10 to the 23. And its units are in molecules or particles per mole. So let's see what our junior tutor said. To answer the question, we have to review first the concept of Avogadro's number. Avogadro's number was first coined by Amedeo Avogadro, who explained that the volume of a gas at a given pressure and temperature is proportional to the number of atoms or molecules regardless of the type of gas. By definition, Avogadro's number relates the molar mass of a compound on an atomic scale to its physical mass. It is the number of elementary particles per mole of a substance. So they called it elementary particles basically because it can go by particles, molecules, or like, let's say you wanted to find number of photons. This is when you would also use Avogadro's number. So the mole is represented by Avogadro's number, which is 6.022 times 10 to the 23 formula units per mole of a substance. As an example, we want to find how many molecules there are in 3 moles of hydrogen sulfide. So if you had 3 moles, you would just multiply it by Avogadro's number, and you end up with 1.8 times 10 to the 24 molecules. Okay, so that was a nice example. So this solution is correct. Okay, so moving on to question 6. What is the formula for calcium chloride? So first, let's break it down into their ions. So the calcium ion is Ca2+, and the chloride or chlorine ion is Cl-. So you'll notice that since chlorine has a -1 charge and calcium has a 2+ charge, then we need 2 chlorine atoms to bond with calcium in order to neutralize the calcium. So I can write calcium chloride as CaCl2. So let's see what our junior tutor said. Calcium belongs to group 2A, hence it has a charge of +2. Chlorine, on the other hand, belongs to group 7A, hence it has a charge of -1. To balance the +2 charge from calcium, there must be 2 chlorine atoms so that the total charge will be -2. Hence, the chemical formula for calcium chloride is CaCl2. So this solution is correct. Okay, so on to question number 7. How many cups are in half a gallon? Okay, so first let's recall that 1 gallon is equal to 16 cups. So if we had half a gallon, so let's say we wanted to find out X cups in 0.5 gallons. This is equal to 16 cups over 1 gallon. So multiplying both sides by 0.5 is the same thing as just dividing it by 2. Which is pretty easy to do, but I'll just show out how the units cancel out. Okay, so 16 divided by 2 is just 8 cups. Okay, so our junior tutor said that note that for every gallon there are 16 cups, so the conversion factor is 16 cups to 1 gallon. Mathematically, this is 0.5 times 16, which is equal to 8. Okay, so this solution is correct. Okay, so on to question number 8. What are covalent compounds? So before I answer what a covalent compound is, I'll first talk about covalent bonds. So a covalent bond is between 2 nonmetals, and it also involves the sharing of electrons. So the opposite of a covalent bond is an ionic bond. So these types of bonds are formed between a metal and a nonmetal. And there is no like sharing of electrons. It's pretty much a give and take of electrons. And this is what forms ions. So ions are just atoms that have a charge. So for example, it's like sodium plus or like chlorine minus. An ionic bond between the two is NaCl. So back to the original question, covalent compounds only contain covalent bonds. So pretty straightforward. If you see a metal in the compound, you already know it won't be considered as a covalent compound because it would have an ionic bond in it. So let's see what our junior tutor said. Before we can talk about covalent compounds, we must first talk about covalent bonds. Covalent bond is a bond where 2 electrons are shared by 2 atoms. Usually, covalent bonds are found between two nonmetals and are denoted by a line between the atoms bonded together by it. Now we can define what a covalent compound is. Covalent compound is a compound with only covalent bonds. To illustrate, let's use water and sodium hydroxide as an example. So here's the structure of water. It has two covalent bonds, two between hydrogen and oxygen. Water only has covalent bonds in it, thus water is a covalent compound. Sodium hydroxide has one covalent bond between oxygen and hydrogen, but also has an ionic bond between sodium plus and the OH minus ions. Thus, sodium hydroxide is not a covalent compound. Okay, so this solution is correct. They also had a great use of examples. Okay, so on to question number 9. What is the density of water? So even if you're not like a chemist, the density of water is actually pretty easy to remember. At 25 degrees Celsius, it is equal to 1 gram per centimeter cubed. Or I can write this as 1 gram per milliliter. So basically, however many grams you have of water, or mils, however many mils you have of water is how many grams there are. So for example, there are 10 grams of water and 10 mils of water. It's pretty easy conversion. Okay, so our junior said the density of water at 25 degrees is 1 gram per centimeter cubed. Okay, so this solution is correct. Okay, so on to question number 10. What is the molar mass of copper II nitrate? So they have the formula written here. Okay, so to calculate for the molar mass of copper II nitrate, let's first find out the different atomic masses of all of the atoms that are involved in copper II nitrate. So there is one copper atom, and if we go to our periodic table, we'll see that copper has an atomic mass of 63.55. So first I'll just show that to find the total molar mass of copper II nitrate, I need to add up all these values together. So there are 2 atoms of nitrogen, and there are 6 oxygens. Okay, so the atomic mass for copper, 63.55 grams per mole. I'm going to do 2 times the molar mass of nitrogen since there are 2 nitrogen atoms. So the molar mass of nitrogen is 14.01 grams per mole. And lastly, I'm going to add 6 times the molar mass of oxygen, which is 15.99. So if we add all these values together, we get a final molar mass of 187.55 grams per mole. So this is the molar mass of copper nitrate. So let's see what our junior tutor said. Molar mass of a substance is the sum of the molar masses of all the atoms in the substance. For copper II nitrate, the molar mass is the sum of all the atoms of copper, nitrogen, and oxygen, which are 63.546, 14.007, and 59.999 grams per mole. And then they just showed out the calculation and got the same answer. So I can verify that this solution is correct. Okay, so on to question 11. What is the change of state directly from gas to solid? So this is called desublimation. I'll write out an example. Let's say you had magnesium as a gas, going straight from the gas to a solid without having like a liquid phase in between. So the opposite of desublimation, as you can guess, is just sublimation. So this is the conversion of solid to gas, again without any intermediate liquid phase. So let's see what our junior tutor said. Deposition or desublimation is the process where a substance goes from its gaseous state to its solid state without first changing into its liquid state. This is the reverse process of sublimation. A readily noticeable example of deposition is when soot deposits on the surfaces of objects after combustion occurs. Soot molecules are gaseous during combustion and cool into its solid state when it loses energy. Okay, so this solution is correct. And they also gave a great use of example. Okay, so question 12 asks, what is the pKa of acetic acid? Okay, so to answer this question, first we need to find out what our Ka value for acetic acid is. So these are values that are usually given to you in a table. Let me Google. Okay, so we see that it is around 1.8 times 10 to the negative 5. So now that we know the Ka value of acetic acid, which is also known as the dissociation constant, we can calculate the pKa. So to calculate pKa is actually pretty simple. All it is pKa is equal to the negative log of our Ka value. So for example, for acetic acid, the pKa is just equal to negative log of the 1.8 times 10 to the negative 5. And this gives us a pKa value of 4.74. Let's see what our junior tutor said. pKa is expressed as the negative base 10 algorithm, yeah, technically, of the acid dissociation constant Ka of a solution. It is mathematically expressed as pKa is equal to negative log 10 Ka. Lower pKa value means the stronger the acid. Acetic acid is a weak acid and has a Ka value of 1.8 times 10 to the negative 5. Solving for the pKa value gives pKa is equal to negative log base 10 of 1.8 times 10 to the negative 5. And they also got 4.74 as the pKa value. So I can verify that this solution is correct. Okay, so now let's move on to question number 13. How would you determine the empirical and molecular formula for hydrogen peroxide, which is 5.94% hydrogen and 94.06% oxygen, and it also has a molar mass of 34.01 grams per mole? Okay, so this is a multi-step question, but before I do any math, I'm first going to make the assumption that there is 100 grams of hydrogen peroxide. Okay, so this makes calculations much easier since they give us percentage values. So for example, step 1, let's say we had the mass of hydrogen over the total mass of hydrogen peroxide times 100%. The question told us that this should be equal to 5.94% hydrogen. So if I assume that there's 100 grams of hydrogen peroxide, if I were to sub that value in for our total mass, so I'm just going to erase this and actually write out, let's say it was 100 grams. Then I can just say that therefore there is 5.94 grams of hydrogen in a 100 gram sample of hydrogen peroxide. So now that I know the mass of hydrogen, I can calculate the number of moles of hydrogen as well. So to do that, number of moles is equal to mass over molar mass. We calculated the mass to be 5.94 grams. And the molar mass of hydrogen is just what you would find on your periodic table, and it's 1.01 grams per mole. So now let's do the math, and you'll notice that our grams should cancel out, and we're left with a value in moles. And you just get 5.89 moles of hydrogen. So let's do the same thing for oxygen. It's 94.06% oxygen. So then I can just simply say that the mass of oxygen, if it was in a 100 gram sample of hydrogen peroxide, it is 94.06 grams. So now I can calculate the number of moles of oxygen. So it's just 94.06 grams divided by the molar mass of oxygen, which is just 16. And you end up getting 5.88 moles. So those are the first two steps. The third step is to divide by the smallest number of moles. So I'm going to write out hydrogen. It was 5.89 moles divided by basically almost the same thing, 5.88. I'm going to show to do the same thing for oxygen. And we get an empirical formula of H1O1. So let me just label that this is our empirical formula. So since they told us already what the molar mass of hydrogen peroxide is, this brings us to step 4, which is just to find the ratio of the molar masses. So the formula weight of H1O1 is just the same thing as the molar masses of hydrogen and oxygen added together. So I'm just going to write just like a small thing here. Molar mass of HO is just 17.01 grams per mole. So this was adding up the 16 and 1.01. So to find the ratio of the masses, if we know that the molar mass of hydrogen peroxide is 34.01 grams per mole, and the formula weight of H1O1 is the 17.01, the ratio is around 1.99, or we can just say that it is 2. So this brings us to the last step, which is just writing out the molecular formula. So let's start off with our empirical. I'm going to multiply the whole thing by 2, and you end up getting our formula for hydrogen peroxide, which is H2O2. So this is our molecular formula. Okay, so let's see what our junior tutor said. Empirical formula is the simplest whole number ratio of the various types of atoms in a compound. So to get the whole number ratio, we must get the number of moles of H and O in the compound. So they also assumed that you had 100 grams of hydrogen peroxide. So they just did it all in one step, but they got the same number of moles. The next thing is to divide by the smaller value of moles, which was the 5.88, and they got an empirical formula of HO. To get the molecular formula, I need to determine the ratio between the formula weight and the empirical formula. So they actually showed out how to get the 17.01, and they got a ratio of 2. So the solution is correct. Okay, so moving on to question 14. How do you convert centimeter cubed to milliliters? So actually, 1 centimeter cubed is equal to 1 mil. So therefore, there's no conversion involved. Okay, so let's see what our junior tutor said. In converting from centimeter cubed to mils, no computation needs to be done because 1 centimeter cubed is equal to 1 milliliter. Yep, so this solution is correct. Okay, so on to question number 15, sorry. How do you dilute a solution? So first I'll write out the definition of dilution. This is simply when you add either more water or whatever solvent you have, but most of the times it's water, to decrease the concentration of a solution. So when we add more water to an existing solution, basically we can recall that the number of moles stays the same. This is because we're not adding or removing any of the solute. We're simply just decreasing its concentration. So if we know that the number of moles stay the same, if we think about the common equation where C equals N over V, we can rewrite this as N is equal to concentration times volume. So if number of moles stays the same and the only thing that changes is the concentration and the volume of the solution, this is how you would get the formula C1V1 is equal to C2V2. So this can also be written as the concentration of your initial solution times the volume of your initial solution is equal to the concentration of your final solution times the volume of your final solution. So most of the times in a question, they'll ask you to calculate the concentration or the volume of a solution if this amount of water is added. So the C1V1 equals C2V2 is just an easy way of finding out your new concentration or volume. So let's see what our junior tutor said. Just to review, we define solution as homogeneous mixtures, which means that its composition is uniform throughout its entire volume. Solutions are made by mixing a solvent and a solute. The solvent is the medium in which the solute is mixed. Solute is present in the solution at a much lower concentration than the solvent. The relative amount of solution component is called the concentration, which is often presented in molarity, which is equal to moles per liter. Dilution, on the other hand, is the process whereby the concentration of solution is lessened by the addition of solvent. This is done if we want to dilute a stock solution, which is a much purer version of the solution, by adding solvent to reach the specific concentration we want. The number of solvent needed is computed using the formula C1V1 equals C2V2. Then they say C1 concentration of your stock, V1 volume of the stock solution, C2 concentration of new solution, V2 volume of the new solution. Okay, so they also have an example. Find the volume of 1 mole per liter stock solution needed to make 10 milliliters of 0.5 mole per liter solution. Using the formula given above, our initial concentration is 1 mole per liter, and we're trying to solve for the initial volume. The new concentration is 0.5 moles per liter, and the new volume is 10 milliliters. So then they just solved for V1 and got 5 milliliters. Okay, so this solution is correct. And they also gave a nice example. Okay, so now let's move on to question number 16. What is the formula for ammonium nitrate? Okay, so let's break it up into its atoms. The equation for ammonium is written as NH4 plus, and the nitrate ion is NO3 minus. So you'll notice that both of these ions have a +1 and a -1 charge. So we only need one of each ion to make ammonium nitrate. Okay, so let's show these ions coming together. To form NH4, NO3. Okay, so let's see what our junior tutor said. The formula of ammonium nitrate is NH4NO3. We got this formula from the name of the compound. Recall that an ionic compound is named by combining the names of the ions that make up the compound. The ions of ammonium, NH4 plus, and nitrate, NO3 minus. Then we combine the two ions. Since both the charges of the ions are of the same magnitude, we do not need to write them as subscripts. Okay, so I can verify that this solution is correct. Okay, so I think we have time for one more question. Simply just asks, what is the molar mass of silver chloride? So first, if you look on a periodic table and try to find the atomic weight of silver, it is 107.87 grams per mole. And the molar mass of chlorine is 35.45 grams per mole. So the molar mass of silver chloride is simply just adding these two values together. So let me show how you would do that. And since there's only one atom of silver and one atom of chlorine in silver chloride, I don't need to multiply any of these values by any subscripts. Okay, so plugging in their molar mass values, gives us 143.32 grams per mole. Okay, let's see what our junior tutor wrote out. In definition, the molar mass is the mass of a given chemical element or chemical compound in grams divided by the amount of substance in moles. The molar mass of a compound can be computed using a periodic table by adding the standard atomic masses in grams per mole of the individual atoms or elements. It is used to compute for the number of moles of a certain compound to give its mass. Compute for the molar mass of silver chloride. we need to get first the individual atomic masses of each element. Remember that for every 1 mole of silver chloride, there are 1 mole of silver, 1 mole of chlorine. Therefore, we need to multiply the atomic masses of silver and chlorine to just 1. Okay, so they just wrote out the different atomic masses. They showed out that just by multiplying by 1 gives you the same values. And they got that the total mass, molar mass of silver chloride is 107.87 plus 35.45 gives 143.32 grams per mole. So I can verify that this solution is correct. Very in-depth explanation. Okay, so that is all the time that we have for today's session. And if you like today's Q&A and you'd like to be notified of when we do this next, then please hit the subscribe button and notification bell below. If you'd like to submit a question of your own, then check out the links in the description. Also, if you like today's video, go ahead and give it a thumbs up and comment. And don't forget to share it with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.